Let's start with the first derivative. What's your derivative of your left side? Tyler, you have this done. What's your derivative of the left side, Tyler?
Negative 3x 2y dx.
Perfect.
Minus 3y.
Excellent. All right. And your derivative of your right side, Lily? 2a to the x, dx, we don't write. Perfect. All right. So, that said, did you get for first derivative something like 2e to the x plus 3y over negative 3x?
Yep.
Excellent. All right. So, you got the first derivative. Now let's talk second derivative. Second derivative means take the derivative of both sides. The left side is easy enough. You just copy the notation. If you're confused, just use the notation I give you. We'll talk more about where that's coming from later. And on the right side, you must use the quotient rule. Okay. So, Mr. Hatch, what's low D high?
Negative 3x.
Okay.
2e to the x plus 3 dy dx.
I agree. Perfect. Minus. Harrison, what's high D low?
2e to x plus 3y minus 3
Times negative 3. Wonderful. Over the square of what's below. Can I leave it the way it is?
No. Yeah. Yes.
You cannot. You must substitute now for dy dx. You are not done. You should write the answer in terms of x and y. So now you need to go back and in place of every dy dx, which there's only one, put what dy dx is, 2e to the x plus 3y over negative 3x. Everything else stays the same. Are we good? Yes? All right. Would you go down to the bottom of the page and let's try one of these to make sure you understand what I'm getting at. 24. Let's try one. So yesterday we talked about how there's a shortcut to finding infinite sums besides all the summation work. And that's the fundamental theorem. This whole thing, the infinite summation, is what that Roman F stands for, an infinite sum. The next thing I would say is this right here. This is step 2, tells me the region is how wide? 3y. Now, obviously, then, that could be a lot of different 3y's. It could be from 0 to 3, could be 1 to 4, could be 2 to 5, could be a million different regions that are 3y. Yeah? Mm-hmm. So now, besides being wide, I also need to know where it starts. Where do I look for where it starts? Or where does this one start?
At 0.
It's
Oh, I mean 1.
1, yeah. Look for the sum. Step 3 is look for the sum in the function to find x initial. Or x initial. The initial x of the region is 1. So it's starting at 1. That goes in the lower limit of integration. And the fact that it's 3 wide tells you the region ends at
4.
4. All right? Now, you say, theoretically, I guess this is really not something you do, but 3 over n represents delta x, yeah? And when this goes really a ton of rectangles, the rectangles get smaller and smaller, thinner and thinner, and delta x approaches the more theoretical dx. Okay, the dx is not just something you write because it doesn't have any. No, dx stands for a really small delta x. The function goes here. What is the curve under which we're finding the area? E to the x. Okay. So your first step is to write a definite, that's called a definite integral. It's an antiderivative with bounds that you need to calculate numbers with. Now, when you go to evaluate a definite integral, you could think of this as 2 steps, maybe 3. What's the first step you definitely do?
You always show the integral.
You always show the integral of the antiderivative. The antiderivative of e to the x is e to the x. You then write this evaluation bar to say, you know what, then after I find this antiderivative, I'm going to plug 4 and 1 in, and what am I going to do with those results? Subtract. So you put 4 in, you put 1 in, and you subtract, and then we have to fight the temptation to say, is that e cubed?
No.
No. Okay, just circle it, you're done. That's not, there's nothing more. All right? Yes?
Could you explain where you got the again because I get 1 but I don't get 2.
So,
Or actually no, I get 4 but I don't get 1.
okay, good deal. So remember that when you go to find this summation notation, the delta x was obvious, but the x of I, or the x at which you draw, that comes from where you start plus how many delta x's you travel over. So for example, if I started at 1 and I were doing right-hand rectangles, then wouldn't the first x at which I drew my height, wouldn't it be 1 plus a delta x? And then the second place I would draw would be 1 plus 2 delta x's. So the starting value is always inside the function and in the sum part of the inside. So E is the function, I'm looking for the sum is here, that 1 is where I'm starting at.
So the 3, would that mean like 3 rectangles starting from
3 is the part of the delta x. This is really the start plus delta x I, right? We said the delta x is 3 over n. And so 1 plus 3 over n, that 3 is more part of the how wide the whole region is. That makes sense? Okay, you bet. Okay, so for the super duper high level of you, okay, to make you think critically. I don't want to lose the people who are just holding on, but to challenge the people that are thinking about this on a really high level, maybe the people that have seen this before. So it's always the question, I get this in BC a lot, they say, I don't understand how you know that 1 is part of the x initial, and how do you know it's not just part of the function? How do you know it doesn't start at 0, and the function is actually e to the 1 plus x, and it goes from 0 to 3? Why isn't it that? Now, if you were to do that, so think of this, y equals e to the x. This is just e to the x, yeah? And we say it's from 1 to 4.
Oh, that changes the function.
Okay, so we're looking at this region, yeah? Okay, if you say this, then how does the shift go? It shifts it left 1. So now the graph looks like this, and you're going from 0 to 3. It is exactly the same.
Wow.
In fact, I'm making you write one function, but I could actually write that infinitely in many ways, okay, depending on where I started from. That said, again, the easiest way to do is just look for the sum and say that's the starting value. So I don't want to confuse you or lose what you're starting to get. But again, just get you thinking. Now, would you set up the integral for the next one as a lead-in to today's lesson, please? Set up today's, the second one. Hi. Congrats. We're warming up with problems in the back. All right, ready? What's the delta x? What's the delta x? Pi over 4. So the region is pi over 4, right? The question is it 0 to pi over 4 or what? Well, yeah, here there's 0 plus, so you don't see any plus inside the function. So it is 0 to pi over 4. What's the function?
Secant squared.
Secant squared, yes. Now, at that point, you're kind of stuck because you don't know the antiderivative of secant squared. So pause, we'll come back to that, and go to the notes. Go to the notes. How many different trig derivatives do you think there are?
Like a billion.
Not a million. There are
7.
12. Sine, cosine, tangent, secant, cosecant, cotangent, and the inverse as well. So there's 12 trig derivatives, of which you know
2.
2, you know sine and cosine. Today you'll learn 4 more, all right? All the non-inverse. This is really pretty straightforward. I'm going to do one with you, and then you're just going to do the other 3 on your own. It's very logical. You don't know the derivative of tangent, but you do know lots about sine and cosine. So it would be logical to say, well, forget tangent. I'm going to say tangent is the same as sine over cosine because I know about those. Now, if I rewrite tangent that way, then that means when I take the derivative, I'll use the quotient rule. So, low
Cosine.
d high cosine. Cosine or negative cosine?
It's just positive.
Just positive cosine. Minus high,
Wait, can you explain why it's positive cosine?
because the derivative of sine
Okay.
is normal cosine. Okay. Okay, so low d high minus high is sine. What's d low? Negative sine of x over the square of what's below. Okay, so what do you make out of the numerator?
Cosine squared minus plus sine.
Cosine squared plus sine squared. Is there an easier way to write that?
One.
One, yeah.
Wait, should the x be?
Should what?
No x for you. We'll just switch it over.
Oh, yeah, sorry, you're right. I made that u. I should have made it. My bad. It's typical to let u just be kind of any function because it could be a chain rule problem. But the more common way to write this is secant squared of whatever was inside to begin with. In this case, it was u over here. Sorry. Okay? So, now, this is important that you memorize this. Now, please, I don't say that lightly because I don't like memorizing as a teacher. I think it's the lowest form of education. But it is necessary in some places. Not because of the derivative, because obviously we have a long way that never fails to get the derivative. It's important that you memorize it because of the antiderivative. If you get a problem like the integral of secant squared, the only way you can do it is if you have memorized, oh, that's the derivative of tangent, so that you can anti-differentiate. And so you will want to study these a little each day and get them memorized. Tangent then, let's just finish this while we're at it. Tangent of pi over 4 is 1. Tangent of 0 is 0. So our answer is 1. All right. You're not gonna forget to do that last one, are you? You're gonna. Oh, okay. Well, maybe you should knock out this one so you don't forget. Will you do that one real quick? And then we'll go back to the notes. What are your bounds? 1 to 2. Okay. What's your function? 1 over x. Okay, what's the antiderivative of 1 over x? Natural log of 2 minus natural log of 1. Remember, you put in the upper limit, subtract away the lower limit. What is natural log of 1? So natural log of 2. You should have absolute value, but as far as when I put in a positive number, you can put it there, but you can blow it off. If you're putting in positives, it's not going to be. So it's okay to not. Okay. So go back to your notes now. We did tangent, I believe. Now let's do, and by let's I mean you do cotangent. That's all on you. Teach a man to fish and all that. free to do the last three. We'll check, make sure you have them right in your notes. Obviously, you don't want to get them wrong in your notes.
Be careful, be careful.
Shut up. Whoa. Whoa.
No. No, it's not. I got negative. It's not a square column.
Oh, I gotcha.
So negative 1 over cosine squared, which is secant squared.
Okay.
Maybe I'll just trip my foot.
You get four.
I fully accept this.
Okie dokie. So, you on second, third, fourth? Second?
That's what it meant. What'd you get?
Okay. What did you get for cotangent? Negative cosecant squared. That's true. If you did not get that, then I'll do it really quick for you. Low, be high, low. There you get negatives on both, so if you factor out a negative, that's where you get a negative outside of sine squared plus cosine squared. That's where they're coming from. All right, so are we cool on that one?
Yep.
You have two choices on the other two. I don't know if you were even aware of your choices, but as long as you can do it one way, that's fine with me. What's one way to take the derivative of secant? 1 over cosine and use the quotient rule, yeah? Okay. Could you use the quotient? Yes, you can use the quotient rule, but could you also say chain rule on the derivative of cosine to the negative first? Yeah, which way did you do it? Quotient rule. Okay, so low is cosine. It's important then that you took d high, right? What's d high?
0.
0 minus high is 1. D low is negative sine. You get positive sine over cosine squared, and that is fine, but that is not the typical way to write this. You typically break this up into sine over cosine and 1 over cosine, so that the derivative is tangent secant. U, not in this case. Over here I should have used.
Is it negative?
It is not negative because
Oh,
it's
wait.
minus a negative. Okay, so it's the derivative of secant is tangent secant, or secant tangent. It's more common to write it secant tangent, honestly. Okay? Derivative of secant is secant tangent. All right, and the last one, did you get it done? Okay, so did you use quotient rule on that? All right, if you did the derivative of 1 over sine, and low d high is 0, minus high Below is cosine over the square of what's below. Did you get negative cosine over sine squared? Okay, let's go more. That's negative cosine over sine and 1 over sine. So what do you reckon the form is? Negative cotangent cosecant. Okay, in terms of memorizing, at least recall or understand that all that start with C are negative. Derivative of cosine is negative. Derivative of cotangent, negative. Derivative of cosecant, negative. So the ones that start with C are negative. Study them a little each day, you'll gradually get them in your brain. Not so much so that you can take the derivative, but you can recognize the antiderivative. Are you with me?
Yep.
Okay, what'd you get out? Fun sheet 46. I want to get 46 fun sheet knocked out to the best of our ability.
Number 5.
It was difficult. Let's go. You want to start with 5?
The hardest math worksheet I've ever done in my life.
Oh, really?
Yeah.
Hey, see, I guess you didn't understand it wasn't a worksheet at all.
Sorry. It felt like a worksheet.
Oh, no, it was fun sheet. Definitely fun sheet with staple. Oh, it didn't even have a staple. Darn it. All right, 5. Let's go there first. This, I don't know if you ever read the Math Curse growing up. It was a kid's book. You know the Math Curse? Okay, this is the Math Curse. You can't even have a cup of coffee without even thinking calculus. Now when I'm waiting for my coffee in the morning and it's dripping out of the pot, relate a rate. Okay? All right, it haunts you. So, the idea is that the water is filtering through the coffee in the cup, or the cone, and falling into the pot below, right?
Yep.
The first start is conceptual / theoretical. So, think of as I didn't ever give you how fast it was going in, which I screwed up, but imagine a cubic inch went in at the start. If it was empty and a cubic inch went in, it might rise that much, yeah?
Yeah.
But a little later, if a cubic inch went in, then the amount it went up wouldn't be quite as big. And then every time a cubic inch went in, it would grow up a little later, a little less. 6 times. You with me?
Yep.
Or it falls out. Okay. So keep that in mind as we go now. When I talk about the radius of the fluid in the cone, as a cubic inch comes in, does the radius change at a constant rate, at a varying rate, or does the radius of the cone not change at all? Varying rate. We just talked about how different cubic inches would cause the radius to change a different amount. So that's a varying, or varies with time, okay? It would vary depending on when you asked. Cool. What about the height of the cone? Would the rate at which the height changes in the cone be different at different times, or always be the same, or it doesn't even change at all?
It varies.
Okay, so that varies with time. Now let's talk the coffee in the pot. A cubic inch goes in and you're here. Then a cubic inch goes in and you're here. So on. So what about the radius in the pot? Does the radius, as this goes on, does the radius change at a different rate? Does the radius change at a constant rate, always the same? Or the radius doesn't even change at all? It doesn't even change at all. If the radius doesn't even change at all, then what's the derivative of the radius of the pot?
0.
Yeah. The radius of the fluid in the pot, it doesn't have a rate of change because it doesn't change. And what about the height? Does the height change?
No. Yes.
Okay, well, the radius doesn't change. The height definitely does change. But does it change at a constant rate or a varying rate depending on when?
Constant rate.
And this is a constant rate. When a cubic inch goes in, the height would always change in the exact same way. Half of an inch or a third, whatever. You with me? Okay, now this part, I failed to give you a given that you needed, so you probably got stuck, and that's my fault. Are we looking at 1/3 pi r squared h or pi r squared h? pi r squared h because it's the coffee in the pot, so it's the cylinder, yeah? Okay. Shall I take the derivative now, or can I get the number of variables from 3 down to 2? Let's get down to 2. Can I put in for the volume? Is the volume always the same, or is the radius always the same, or is the height always the same? The radius is always 3. So we could say that the volume is 9 pi h. That's a heck of a lot easier to do calculus on than a product rule derivative with 3 variables, yeah? So you should always strive to get the number of variables down to 2. Now let's take the derivative with respect to time. dv dt is 9 pi dh dt. Now it says at what rate is the height of the coffee pot changing? That's great. I want dh dt. Unfortunately, to find dh dt, I would need to have been given dv dt, and I forgot to give it to you. Sorry.
That's why I couldn't.
Yeah, so that's, if you got that far, then that's totally, your calculus is awesome, the rest is on me, I screwed up.
I just stopped and thought, like,
Yeah, there's nothing more to do, because I forgot to give you how fast it was coming. My bad. Okay, so just stop there, and if I gave you dv/dt, then you can continue. You cool?
yeah, cool.
Okay, what else would we like to talk about? 6.
Also, number 60.
Okay, let's get all of 6 going here.
6 and 7.
All right, so I'm going to use this balloon here. Yeah, isn't that honey? So this balloon is rising. Let's assume it's rising straight up, because if it's not, that makes the problem a lot harder. And let's go. Let's complete the picture. Looking at all this, it says rising at a rate of 5 meters per second. At the time, it's 30 meters high. So tell me this. Can I put in 30 meters here?
No.
Okay, always, before labeling anything in your picture, say, is it always that? And yes, it's okay to put it in, or no, that's varying, don't put that number in. Is it always 30?
No.
No, so do not put 30 there. It is not always 30. Instead, if this balloon is rising, it's varying. You should actually call that a Y, and leave the 30 to some other stuff. That's probably the wind, not the always 30. All right, it's tethered to a rope diagonally that's 50 meters long. So this is the rope. Is it always 50? If the balloon rises, will that rope have to change?
No.
Okay, if it doesn't change, then is the balloon then going to have to go whoop? We don't want that. Okay, so that makes the problem harder. So let's just assume they say currently 50 meters long. To me, that currently says that that's not always going to be the case. So I'm going to call that R, and that 50 is more like the instant they ask about. The instant that the height is 30 and the rope is 50, that's more like the wind case. This is the wind case. You follow? Okay, you can see in part B that they also talk about the angle of elevation. That's true. The area of the triangle, that's base times height divided by 2. We might need that base. Is that base going to stay the same? Okay, so what is the base? Look down here. It's 40. So call that 40. 3, 4, 5 triangle by unit multiplier. It's a primitive, yeah? Okay, now that 40 I feel like is constant, and that picture to me tells all. All right, so let's get going here. We typically say the given. Rather than write the given every time, I'm just going to write it up here. When they say it's rising at a rate of 5 meters per second, as far as the givens, you should always look for rate, because that'll often tell you what's the given in calculus terms. So what is being given? dy dt, or if you called it h, that's fine, obviously. Dy dt is it 5 meters per second or negative?
Positive.
What word tells you positive?
Rising.
Rising, okay. All right. When they say the question then, at that moment, find the rate of change for the rope's length, what do they want? dr dt, and when do they want it?
What are you now?
When y is 30 and when r is 50, yeah? And y is 50 and r is 30 and y is 50. You follow me? That's the instant they talk about? Really cool?
Yeah.
Okay, so I look at the picture, and each time the equation could be different, but when I see triangle, I think either similar triangles, Pythagorean theorem, or trig. What do you want to do? Pythagorean theorem. So by Pythagorean theorem, 40 squared plus y squared is r squared. That's two variables, so at least I don't have to worry about substituting. You can narrow the variables down. Let's differentiate with respect to time. What's the derivative of 40 squared with respect to time? 0. What's the derivative of y squared with respect to time? 2y dy dt. The derivative of r squared with respect to time? 2r dr dt. If I dump the 2's, are we cool with that? Let's sub in. What can I put in for y? 30. What can I put in for dy dt? Oh yeah. What can I put in for dy dt? 5. What can I put in for r? 50. And dr dt is that which I'm looking for, yeah? So what'd you get for dr dt? 3 meters per second. Does it make sense that the rope length is growing? Okay, yes. All right. The angle of elevation, including that with the question, they want the rate of change for the angle of elevation. So what does that mean in calculus? Find d theta dt when? Again, y is 30, x is, or r is 50, yeah? So you have a couple choices here. It's really up to you. Looking at this triangle, obviously I want the angle, so because of that I feel like trig is the direction we're headed. What trig function? Sine makes sense, but it's got 3 variables. That's kind of What else? I reject sine. I say you shall not do sine. What else? Cosine is good because at least it has only 2 variables, and you know cosine's derivative, so that's a good way to go. What else could you use? Tangent wouldn't be bad either. That's opposite to adjacent. Now, when you were doing this worksheet, you didn't know tangent's derivative, so you probably, I hope you shied away from that. Let's do cosine, shall we? So cosine of theta is adjacent over hypotenuse, so that's 40 over r, right? Let's differentiate with respect to time. What's the derivative of cosine with respect to time? d theta dt equals, by quotient rule, low is r, d high is 0, minus high is 40. What's d low? dr dt over the square of what's below. All right. Now you guys have made it clear you prefer to substitute in first. So I'm down. Negative sign, I know students are always tempted to pick up the calculator here. This can be done without a picture here. Look at the picture. What is the sign of theta? SOHCAHTOA. 30 over 50. Right? Or 3/5. d theta dt is that which I'm looking for. We're cool. This is 0. Negative 40 is fine. What's d r dt? 3. Yeah, I just found that over here. It's 3. And what's r at the instant? 50 squared. All right, so isolating d theta dt, the negatives wash out, yeah? Okay, so we have 40 times 3 over 50 times 50. I'm just going to write that. I find it easier to cancel. And we can either call that 3/5, or should we leave it 30 over 50, because then a 50 will drop out. You see what I'm saying? When I bring over the 30 over 50, it's reciprocal, so 50 over 30, then a 50. Okay? And maybe a 3. And then maybe a 10. So, 2 over 25 is, I feel like, the simplest possible answer. 2 over 25, now the only hurdle is the units.
Degrees.
If you took a derivative of sine or cosine, you're in radians. The derivative, if I say, hey, you're in degrees, what's the derivative of sine? Not cosine. Sorry, all of calculus is based on it being in radians, not in degrees.
What about in degrees? What's the derivative?
Cosine times pi over 180.
I didn't hear that. I didn't hear that.
Yeah.
Let's just not.
So, yeah, if you're doing calculus with trig, it's in radians. D theta over, my bad. So, d theta, the units change in the angle is radians, and the change in time is seconds. The angle is increasing at a rate of 2/25 of a radian per second. Okay. Are we with me? Are we with me? Are we with me?
Yeah.
Cool. In C, we want the change in the area when y is 30 and r is 50. I don't think the r matters in this case, but whatever. What's the equation you'll use if you want the rate of change of the area? 1/2 base times height, and base is
40.
40, and height is y. So it feels like the easiest equation is area is 20y. Differentiate with respect to time. dA dt equals 20 dy dt, so dA dt is 20 times 5. What are the units on our 100 answer? 100 meters squared per second. The area is growing by 100 square meters every second. Okay? Okay, what else would you like to talk about? Number 7.
One sec, real quick, please.
Okay? All right, this one?
Yep.
This one's tough. All right. A picture is helpful. So there's a particle here on the parabola, and it's moving along the path. This actually is a pretty big Calc 2 question. Okay, it's called arc length, but that's for another day. They're saying, as the particle moves, how does the distance between the origin and the particle change? So it's big, but it's getting smaller and getting smaller, but then it's getting bigger and getting bigger. So there is obviously change in the distance from the particle to the origin. How fast is that distance changing at the point the particle is at 1, 2? All right, so given, what are you given? Dx dt is 1.5 units per second. All right, what do you want? The ddt when the xy is 1, 2, yeah? Okay, great. I got a picture that makes clear what d stands for. I got the interpretation of the given. I have clearly in my head what I want to find. Now what do I do? I need an equation for that which I want to find. So, what is an equation? So y equals x squared plus 1 is very logical, but I want to change in the distance. Where's the distance? There's no distance there. You're barking up the wrong tree. Okay, so you will use that. Obviously, you're going to use that at some point, but not now. Give me an equation for the distance between the origin and some point on the curve. Big square root. X squared plus y squared because of the 0, 0, yeah?
Yeah.
All right, cool. Now what? Should I take the derivative with respect to time? No, you don't take the derivative when there's 3 variables if you can help it. You can help it. So what should you do next? Plug in for you could actually go one of two ways. You could plug in for x squared, or you could plug in for y, whatever you want. Which one's easier? It's actually easier to plug in for x squared. What can you put in for x squared?
Y minus 1.
Yeah. Now you could also substitute in for y with x squared plus 1, but then you've got x to the 4th. It's a little uglier, yeah? Much cleaner to go in for x squared. Okay, so if I take the derivative with respect to time of y squared plus y minus 1 to the 1/2 power, then what is the derivative to the left?
1 dd dt.
dd dt, and the derivative to the right. 1/2 y squared plus 1 minus 1 to the negative 1/2, which would mean a root in the denominator, yeah? Times, by chain rule,
2y.
5 plus 1 times chain rule again,
Q.
y d
T.
t. That derivative takes go because it's two chain rules. Okay, you good? All right, let's go substituting. dd dt is 1/2, cool. 2 times, what goes in for y? 2. In the denominator, instead of y squared plus y minus 1, it's 2 squared plus 2 minus 1. And what is, shucks, poop. Well, you don't know dy dt, yeah? That's okay though, because there's an easy way to find it. Go over here. Isn't y equals x squared plus 1 true? So what is dy dt? 2x dx dt, yeah? What's x? 1. Right?
Wait. Oh, yeah, sorry.
1. And what's dx dt? 1.5 or 3/2. So what's dy dt? 6/2 or 3. All right, now we got it. Now we're rolling. We had to do a little side calculus. That's all good. So we get something like, we got your 5 over 2 root 5 times 3. We? So 15 over 2 root 5. What are the units on that? Units per second. It's distance over time, so it's units per second. Okay? Others. Next one. Next one. Okay, sand is pouring in at a rate of cone-shaped pile. Okay? You have the radius of and the height. What are you given? When it's pouring in at a rate of 2 cubic feet per second, what are you given? VDT, is it positive or negative change in volume? Positive because it's pouring in 2 cubic feet per second. You're also given that the height is always twice the radius. I'm not sure how to use that yet, but we'll get there. What do you want and when? HDT when? Okay, cool. So what's an equation for this? Third pi r squared h. Oh, that's great. Take the derivative now or not yet?
No.
3 variables, try and get it down to 2. Shall I put in for h or put in for r? What do I want to find? I want dh dt, so h needs to be in my equation. So I need to keep h and sub for r. R is 1/2 h, so 1/3 pi, and instead of r squared, it's h over 2 squared. So I get something like pi over 12 h cubed. Do you concur? All right.
Good morning, Dublin Jaguars. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which which it stands, one nation, under God, indivisible, with liberty and justice for all. All students, please join the SWE Next Club this Friday, 7th hour in Miss Newcomb's room. It's in Miss Newcomb's class to watch videos provided by Lockheed Martin of the Lucy Space Project in Jupiter. Popcorn and drinks will be provided. It's spooky season, Jags. You know what that means. Devlin's Trick or Treat Street is on Friday, October 18th from 6 to 8 with an improv show at 8:30. All participating clubs, please make sure to collect candy and leave enough time to make decorations. Spread the word throughout the community so we can have another great Trick or Treat Street. Today, Savannah College of Art and Design from Savannah, Georgia will be in Miss Lawrence's art room during 7th hour. Bring your art portfolio. They also offer many more creative features such as advertising, animation, and cinema. On Thursday, Cal Poly at San Luis Obispo, California, and University of Alabama from Tuscaloosa, Alabama will be in counseling. Juniors, tomorrow is the PSAT exam. Remember to please be here at 7:15 a.m. to your designated testing area and settle in before the test. Be sure to bring your calculator and number 2 pencil. You can bring snacks and water to have during break. As soon as the test is concluded, you will be dismissed for the day. 10th graders, if you notice in your planner the 10th grade Game of Life is scheduled for this week with counseling. It has actually been rescheduled for the week of November 4th. Seniors, don't forget to turn in your graduation contracts if you do not have one, stop by counseling to get one. Seniors, don't forget to apply to Colorado colleges and universities for free tonight. Megan Place is a child care specialist is hiring students 16 years and older to play with children with developmental disabilities. Flex hours, fun work environment, and a life-changing experience. Check out the job opportunity board or stop by counseling for more information. There will be a pre-season information meeting for parents of female swimmers on Wednesday, October 23rd at 7 o'clock in the auditorium. Dazzling Jags, come watch volleyball tonight against league rival Stanley Lake at 6:30 p.m. Go Jags! Congratulations to the marching band on a remarkable regional performance. The band earned the highest score in Devlin history, an 81.4. They were the grand champions of the marching event. Go Jags! Hey Jags, it's time for your daily day of the day. Happy Colorado Apply for Free Day! That's all your announcements, Jags. Have a wonderful day.
I know your parents are grateful because that stuff didn't have to do.
It's like my fault.
Yes.
Do we keep that 47?
Yes, you can keep 47. I'll take it to, well, not tomorrow, sometime. Someday we'll turn it in. Actually, juniors, seniors, is there any reason you can't turn it in tomorrow, or no, you're going to be with us? No. You're good. There's no reason you shouldn't turn in 47. Yeah. Do you have your applications all ready and done? Are you applying to Colorado schools?
Yes.
Excellent. Keep in mind, your parents have already paid for part of your tuition and paying your taxes in the Colorado funded schools. Not the private ones, obviously. Another one, sorry, hope this is too late. All right. Marcus. Okay, so if you're a junior, I would get on the website tomorrow, under tomorrow on the calendar, and watch the videos so you know what we reviewed for the test. I will also be here before school Thursday to review for the test, if you want to review for the test Thursday morning. 45. Not yet for really late. Have a lovely day.